All right, welcome to our next talk at YYConf 2013. We have a really special talk today. This is the building blocks of prototyping with Lauren Tsung. So everybody give Lauren a big hand.
Hello everybody, I'm a prototyper for the platform's advertising user experience team at Yahoo. And today, I'm going to be giving you my take on the building blocks of prototyping. First, I'll begin with the backstory. I used to design experiences for the developer platforms and services team at Yahoo, and we had a Lego culture. In fact, it was a Lego craze. And during our lunch breaks, we would go to the Lego store. And one of the sets that I purchased was a Taj Mahal Lego set, which comprises of 5,922 pieces, one of the rarest sets out there. I think it's very important as professionals to reflect on the principles that we use every day without knowing it. And I think it's important, especially in this industry, where we need to innovate, to question what we find meaningful. I'm going to be using the Taj Mahal Lego set to help us reflect and to do just that. At its core, prototyping is a means to quickly assess or validate a concept. So first, I'm going to be talking about some engineering methodology with respect to evolutionary prototyping. Then, I'll talk about a partnership that needs to happen between engineering and design. And then we'll discuss how prototyping is used as a learning device. So first, I'm going to be talking about evolutionary prototyping with respect to an agile-like methodology that I use with my team to build this project. Almost every project, especially software projects, begin with chaos. Whether it's your customer has no idea what they want, engineers haven't figured out their architecture, designers haven't figured out their mocks. Things begin in chaos. And before we can talk technical details, you must iron out your team culture. And that's precisely what I had to do with my team. We took 3 days to build out this project. We had to figure out our sprint cycles, our cadence to meet up. We needed to unblock each other. We needed to figure out how to test thoroughly to control this chaos. And before you begin your first line of code, realize your development patterns quickly. So here you see a diagram of the real Taj Mahal and the onion dome that rests in the center. You see these 4 columns called minarets. You see some mini domes and the arches that form this symmetrical system. Now, as engineers and prototypers, it's our responsibility to figure out, okay, how can we abstract this out? How can we meaningfully use inheritance? What object-oriented paradigms make sense before we use our first line of code? So I'll talk about a couple of principles that are pretty relevant to this particular Lego project. The first being abstraction. So you can see that Lego designed a 3-tiered system, what I'm calling 3 layers of abstraction. And what's great about abstraction is that I can meaningfully focus on my area of the project without having to deal with the unnecessary overhead of the entire system. I worked with another developer on the base, and the 2 other developers focused on the middle tier and the top tier respectively. So what's interesting about our building process, we still needed to understand what the other tiers looked like. As we were building pieces, we had to unblock what we were doing with respect to our own tiers, but we had to ultimately figure out how to focus and meaningfully integrate. Speaking of integration, there was a really great interface between these tiers. So for example, there was a unit, an input and output mechanism that allowed the tiers to snap naturally in place. But observe that this is a loosely coupled system. So not only did the interface needed to allow for natural snapping in, things needed to snap out so that you can have these layers of abstraction that can be easily maintained. Observe a diagram of the base of this system. And what's really cool about these intricately designed blocks is that they afforded which tier they belong to. So, for example, you see this tannish cylindrical little piece. It definitely it belonged to the base. And the fact that Lego coded it in this way, it allowed us as developers to figure out, okay, every time I see this particular piece that's unique to a tier, it's pretty easy to maintain that layer of abstraction. Another core engineering concept is making reusable and self-contained components. So here is another diagram of the base. And you can see here, everything is again loosely coupled. There is a meaningful layer of intersection between each piece. You can see the 4 rods that connect things naturally for things to snap in place and for things to disconnect. And what's great about having self-contained components, it allows for easy and thorough testing. It allows for reusability, rearrangeability. If this were a monolithic system, it'd be very difficult to debug. And this design allows to pinpoint that error if necessary. So speaking of testing, we had to have really thorough testing and frequent testing in our build process. So what you see here, the above diagram, is basically the specification LEGO provided that told us how to build each unit. And some great test cases is that the test should describe exactly what it expects from a unit. So as we were building each unit, we had to constantly verify against the test case to see if it passed. And once it passed, we went on to the next unit. This methodology allowed us to have confidence in our system as we were building it. We did run into an error, mainly towards the very end of the 3-day cycle, where we found one piece that was kind of dangling out of nowhere. Things looked a little awkward. But because LEGO designed 3 layers of abstraction, because each piece afforded which tier it belonged to, because things were self-contained and well modularized, and because we tested thoroughly, we were able to debug relatively quickly. So I talked about some really core engineering concepts that are pretty core to evolutionary prototyping. Now I'm going to talk about how engineers need to partner in design for the purposes of prototyping. One of the most important things to do in design is to really understand the mental model of your users. I scraped the LEGO website to see any comments about the Taj Mahal LEGO set. One quote reads as follows from this 13-year-old who represents a key persona in their target demographic. It did become boring and tiresome when constructing the 4 archways and 4 corners that make up the body of the palace. But, unlike most reviews suggest, I did not have a problem whatsoever finding the pieces I needed for each step, and I did not organize to start with. I made a little map in my head of where the bags for different pieces were on my table and was able to find them quite easily. Oh, and keep in mind, I was only 13 years old. This quote was really powerful to me. Just think of how we can create maps in developers' heads as they're making prototypes, as they're quickly making interfaces with designers. So one concept I recommend is to enable efficient and meaningful development. And one practice would be to make a design pattern library. Allow developers to group similar pieces together, and it's up to a culture between engineers and designers to see which use cases each piece belongs to, so that the development can be quick, efficient, and consistent. Another important concept that belongs to both engineering and design world is to show accountability down to the last detail to the user experience. So something that LEGO is actually pretty famous for is that none of their sets go missing with even one piece. And think about the scale they have to release these sets. How can we borrow that concept in software? How can we make sure that every pixel is crisp? How can we ensure that our code ensures optimal performance, is robustly tested? How can we show the utmost accountability to the user experience? So I began this talk talking about some key engineering concepts with respect to evolutionary prototyping. I talked about the partnership that needs to happen between engineering and design to show accountability down to the last detail. Now I will talk about how prototyping is a learning device. So with this project, my team and I, we use evolutionary prototyping with our Taj Mahal set. But we should be aware about the different fidelities that exist for prototyping. Discern the fidelity of your prototype. The real system, the real Taj Mahal, took 22 years. We can't afford that in software. We have to move really quickly. Requirements change all the time. In fact, many of the times requirements are unknown. We need to be able to set up for quick pivoting. And to do that, we need to discern the fidelity of the prototype. Choose which use case you're testing and what type of prototype makes sense to test that use case very thoroughly. One practice I recommend if you just want a really quick and dirty solution is to do something called paper prototyping. You can see this little sketch here of the Taj Mahal that quickly illustrates, okay, rather than going towards the most robust system you can make, aspire to choose the lowest fidelity if you just want to get a concept out. And again, it all depends on what you're testing to see what makes sense for the job. And as you're distilling requirements, as you're fleshing out your use cases to prototype against, capture the essence of your product. So the intention of the Taj Mahal was to actually honor the emperor's favorite wife, who's buried at the center of the structure. And you can see that I talked about how this Taj Mahal is actually a symmetrical system. And here you see the middle tier of a Lego system. You see the bird's eye view and the inner guts of that middle tier. Everything is symmetrical, the tomb that rests in the center. So I believe Lego captured the essence of this product by capturing all the lines of symmetry, especially in the middle tier. And we can verify this by looking at the real Taj Mahal, how even the outskirts show symmetry with respect to the tomb in the center of the structure. And as your prototypes come to life, as you're building a rapport with your users, discover what delights users deeply. So here you see some pictures of the real Taj Mahal, some details that are not as easily seen in the facade. You see an artist at work carefully crafting a new tile of paintings. You see some carvings, you see some scripts, you see some really cool art. All these details, all this passion, that's all embedded in the details that are not easily seen in the immediate architecture facade. How can we apply that in software? How can we delight our users deeply? So I began this talk again talking about evolutionary prototyping and talked about some core engineering principles to do just that. I talked about a deep partnership that needs to happen between engineering and design to be accountable down to the last detail in user experience. I talked about different fidelities of prototyping and choosing the appropriate fidelity for the job. And before I begin talking about these takeaways, I recognize that no metaphor is perfect. I recognize that software is not symmetrical, and I recognize that requirements are not static. But there are 3 takeaways with this project. The first takeaway is to harmonize the efforts between design and engineering, because beauty will illuminate from the inside and out. So you can clearly see when you have that partnership between design and engineering, things flow. You can control that chaos. Things seem to be rapidly prototyped in the most consistent way possible. That's what you can see in the actual Lego system. Things were engineered and designed so well that a 13-year-old was able to make maps in his head. The second concept, a product's integrity directly correlates to process and tenacity. Again, it all boils down to team culture. It's how you test. It's whatever your cadence is to meet up. It's how you unblock each other. Whatever it is, your product's integrity will definitely correlate to your process. And that definitely showed up with my project, with my 3 other team members. We had to have that tenacity for the 3 days we built that system. We had to be really tenacious about our testing process, especially when it came to debugging that last piece. And my final point, last but not least, find the miraculous in the mundane, or something that's seemingly childlike, because deep insight follows. You can look at this Lego set as just another child's toy. But in all honesty, Lego did a really excellent job at teaching some core engineering and design principles that we can reflect on. And again, in our industry, where it's so competitive, where we need to innovate, and we have to check upon the principles that we use every day, try to find inspiration that's not necessarily software. Find inspiration from the mundane. Thank you.
All right, we have time, about 10 minutes for questions. I have questions for Lauren.
Oh, and by the way, for those who are interested, I actually brought 2 pieces of the Taj Mahal. If you're interested, this is part of the dome. And this is one of the self-contained units from the base, so you're welcome to take a look if you're interested.
I think what's amazing is just how intricate those are and how much work it goes into just one little piece.
Absolutely.
All right, let's start. Give me some questions.
Yes.
Come in.
So from start to finish, did you develop that project, at least the metaphor of the project, in a modular manner, or did you, because I know you mentioned that you broke it into, say, an N-tier system, 3 different tiers, and you had 3 other team members, and you devised probably the first 2 were you and someone else on the base. Within that system, breaking it even further, were you developing it modularly at that level? So for example, the base, you looked for reusable components, you looked for patterns that could be repeated, and pieces that you could build individually, but so that you had a sort of a machine process to go through, so that instead of looking to build piece on piece, you look to build component by component.
Yes. So let me just clarify my answer here. So yes, these sort of broken down into 3 layers of abstraction. We were able to work in parallel. And with the other developer on the base that I mainly focused on, we built our respective units, and we verified against each other's work against the test cases before we moved on. So yes, we had to work at a modular level.
All right.
So my question might apply just particularly to the team that I'm working with. So in front-end engineering, let's say you have components like Bootstrap or some CSS and libraries. I still see that there's some kind of disconnect between the components that you could possibly use and then what you actually build, because there's some confusion. So what are your thoughts and suggestions regarding how we can use this model?
Sure. So it depends like what you're trying to build, right? Could you clarify that more? Can you give me, are you allowed to give me like a specific use case that you're trying to build against?
Sure. Okay. So let's say that I'm trying to build a module where it has a table of stats and it's interactive, but this page of stats could be used elsewhere with maybe slightly different stats or parameters. I could definitely see the table as maybe a self-contained module with many things to break down, but there might not necessarily be a good way to do it right now. I mean, we have the code structure in place, we have the styling guidelines in place, but I still feel there is something missing with regards to prototyping. So we always have to end up optimizing for edge cases or some sort of specialization. I could understand that, but I would still like to see that a little bit more formalized.
Sure. So what I would recommend, and it's not necessarily what I did with the LEGO system, but iron out what's your MVP, figure out what exactly is the test that or the use case you're thinly trying to prototype against. If you're still very uncertain, try not to use code. Go to paper prototyping, especially if it's a user interactivity sort of thing. Try to make sure that is usable. Make sure that's legitimate before you try to partition, okay, what do I need to code here? If you can avoid styling things and you're just trying to figure out like one function, put that in isolation, make sure it works and is well self-contained before it expands. So I guess what I suggest, really try to check what your MVP is before you try to scale things out.
Actually, I had a question. When you're dealing with a team like this, and say one of the team members is not catching up with the rest, like all the rest of the team is done, but this one team member is not keeping up, how do you deal with that? How do you account for that?
Sure. I would like to liken that to pair programming. Sometimes it's really beneficial for a more experienced developer to be paired with an inexperienced developer. And so let's say I was the one, and it's probably likely that I was the slowest LEGO builder. So someone who's definitely more experienced can take a look at my work and offer me suggestions. Okay, I see where you're going. You see these bags. How can you quicken up your pace and be organized about it? So I definitely think you can use some pair programming sort of methodology in LEGO building if necessary.
Very good. Any more questions?
What other intersections do you have with LEGO and front-end engineering?
Could you clarify that question?
is there any other way we can use the concept of Legos with front-end engineering?
Okay, I don't want to get into a holy war, but I've been reading articles around separation of concerns, and I would recommend how if we were to use Lego as a true sort of analogy, discern, okay, if whatever you're talking about self-contained, what about the inherent structure of that self-contained unit can inspire us in the digital realm? So if we're concerned about separating presentation from markup and behavior, how can we discern that sort of concepts with respect to something physical? So I guess to answer your question, I think we can easily map some concepts from the physical realm to the digital realm. We just have to be more abstract about it, more meta.